Assalamualaikum warahmatullahi wabarakatuh and good afternoon. I'm Muhammad Suhaimi, a PhD student in University of Science Malaysia. Okay, today I'm going to present the finding from my previous study, which is entitled Effects of Prolonged Running in Different Environmental Conditions on Selected Physiological Markers, Muscle Damage, and Time Trial Performance in Recreational Athletes. Okay, during prolonged running, athletes generate and dissipate large amount of heat, which subsequently increases the core body temperature. The increment of core body temperature is faster and higher when the athlete run in hot environments. Heat has been recognized as one of the critical factors that limit the exercise performance. However, to date, the study on the effects of heat on exercise performance among heat-adapted athletes are not well established. Therefore, the present study was conducted to determine the effects of prolonged running in the different environmental conditions, which were in the hot versus thermoneutral environment on selected physiological markers, muscle damage, and time trial performance in heat-adapted recreational athletes. For the methods, let me explain the flowchart of the study design. 12 recreational athletes were recruited as a participant in the study. The participants were healthy male aged between 20 to 35 years old and exercise regularly, which is at least 2 times per week and at least 30 minutes per sessions. Then the participant undergone a preliminary trials, which include submaximal and maximal oxygen uptake test, VO2max test. The data from the submaximal and VO2max test were used to determine the running speed for warm-up at 50% of their VO2max, and then the endurance running performance at 70% of their VO2max. The participant then performed the familiarization of the experimental trial at least 1 week before the actual trial. The participant must be able to run for at least 60 minutes in the heat at 70% of their VO2max. The participants who were unable to cope with this test were excluded from the study. Then the participant underwent a randomized control trial where they performed 2 different trials in a hot and thermoneutral environment. The 2 trials were separated by 1 week recovery periods. The heat trial were performed in the improvised heat chamber. The heat environment was maintained at 32 Celsius by using halogen lamp, and whereby the thermoneutral environment was set at 25 Celsius by controlling the temperature on the air conditions. A water bath was used to maintain the relative humidity at 70% in the heat chamber for both trial, and a standing fan was used to direct air to the participant to mimic the airflow in an open air environments. The relative humidity and temperature of the chamber were measured by using the digital psychrometer. For the statistical analysis, the data was analyzed by using the statistical package for social science version 25. The significant difference in time trial performance between trials was determined by using the student PATI test. ANOVA with repeated measure was performed to determine the significant difference in physiological parameter between 2 trials over time. The acceptance level was set at p less than 0.05. Okay, next, let me brief the experimental protocol during the actual trials. On the morning of the test day, the participants were given a standardized breakfast, which was a piece of bread. 3 meals per kg body weight of plain water were given 30 minutes before the warm-up at the start of the trial, and every 20 minutes during the trial. Then the participants were asked to empty their urinary bladder, and nude body weight was recorded before the warm-up and after completion of the trial by using an electrical body composition analyzer. The heart rate of the participant were measured by a heart rate sensor throughout the trial. A blood sample of 0.8 ml was collected at the start of the trials and every 20 minutes throughout the trial. Once the participant ready, they enter the heat chamber to perform the running performance, either in the hot or thermonuclear environments. The participant then had a warm-up for 5 minutes at 50% of their VO2 max on the treadmill. Then the participant ran for 60 minutes at the 70% of their VO2 max, and immediately followed by 20-minute time trial performance. The participants were encouraged to run the longest distance as possible in 20 minutes by controlling the speed of the treadmill. After completion of the trial, the participant cooled down for 5 minutes. The participant then towel dried themselves, and their post-exercise new body weight was measured to determine the percentage of body weight loss. The participant performed the same trials in different environment, either in the hot or thermonuclear environment, 1 week after the first trial. Okay, next we look at the results and discussion. Okay, according to the results, the room temperature was maintained at 25 Celsius for N trial and 32 Celsius for the H trial. The relative humidity of the chamber was stable at 70% for both trial. This indicated that the room temperature and relative humidity was stable and well monitored throughout the trial. Here we also can see that there was no significant difference in fluid intake of the participant for both trials. However, body weight changes and sweat rates were significantly higher in heat trial compared to the N trial. Even though there was a significant difference in body weight changes between the trials, the hydration status of the participant was still considered as mild dehydration, which was 1 to 2%. Okay, in the present study, we found that the running performance of the participant was affected by the hot and humid environments. The running distance of the participant in the N trial was 310 meters further compared to the H trial. The present observation was similar to the previous study by McAnally 2005 and Walter 2000. However, most of the studies were conducted on humans adapted to live in a cooler environment and who were either non-acclimatized or partially acclimatized to heat. However, our study confirmed that exercise in the heat limit the endurance performance significantly in participants who had always lived and trained in hot and humid environments. For plasma lactate concentration, even though there was no significant difference between both trials, however, at the end of the time trial, plasma lactate concentration was higher in N trial compared to the H trial. This was probably attributed to a faster pace when the participants were running in a cooler environments. For plasma volume, there was a significant difference between N and H trial. The plasma volume decreased more in the H trial compared to the N trials. This was probably due to more fluid loss through sweating during the exercise in the heat. Lastly, for plasma creatine kinase activity, it was significantly higher after 24 hours post-exercise compared with the resting level in the N trial, but not in H trial. However, there were no significant differences on plasma creatine kinase activity between H and N trial. This means that factor others than heat is responsible for the occurrence of muscle damage. The possible causes that contribute to muscle damage were the eccentric muscle contraction during exercise. As a conclusions, it is indicated that hot and humid environments impair the prolonged running performance of recreational athletes. The recreational athlete ran for a longer distance in the thermonuclear environments as compared to the hot environments. However, prolonged running in the heat does not seem to have any effects on plasma lactate and muscle damage. It is advisable to all coaches and athletes to take consideration the effect of heat as a critical factor that may affect their performance. They should take any possible strategy or approaches such as heat acclimatization or pre-exercise cooling intervention to maintain or improve their performance in hot and humid environments. Thank you.